Okay, this is 6.1, solving systems by graphing notes. The first 3 questions is basic vocabulary. Okay? Systems, I'm just going to tell you, systems is where we have 2 or more lines. Okay, so 2 or more equations. The first part, a blank is where 2 lines intersect at a point. This is going to be a solution. So let's write solution in there. A solution is where 2 lines intersect at a point. Okay, looking at these 3 graphs. Can you guys see them? Okay, you do not have to write this down. Looking at these 3 graphs. When we did parallel, perpendicular, we went over this just a little bit. Okay? If I told you a solution is where they cross, then right here is going to be our solution. How many times did they cross? Once. So this one is going to have 1 solution. It's 1 solution, and that solution will be where they cross. That point is their common point. That's where they are the same. Okay? What were these lines here? Parallel lines. If a solution is where they cross, how many solutions do parallel lines have in common? 0 solutions, right? So this one's going to be no solution. And the third type, there's actually 2 lines there. What did we call that? You're close. Coinciding. Okay, these are coinciding lines. How many do they have in common? All of them. So our solution here is going to be all real numbers. No, they don't need to be writing this. Okay, so this is all real numbers. So if it's coinciding lines, they're going to have all real numbers because all the points that they have are in common. Is everybody clear on that? Okay. So back to our note page. When 2 lines in a system do not intersect, they are what? Very good, parallel. And the third one, coinciding lines have? Very good, all real solutions. Okay, part 1 says, tell whether the ordered pair is a solution of the given systems. So if I'm giving you 2 equations in an ordered pair, what's the easiest way for us to check and see if that ordered pair works? Very good. Fill it in. So let's do that. So for the first one, 3x, so I should write 3 times 2. Very good. Plus -2 equals 4. So when I rewrite this, I should have 6 plus negative -2 equals 4. Is that true or false? True. So the first one's good. That order pairs on that line. So the second one, I need to have 2 minus 3 times -2 equals -4. So when I rewrite, I have, no. What do I rewrite? 2 plus, what's 3 times 2? 6 equals negative 4. Not true, is it? So this is not a solution. Negative 2 only works on one of the lines, not on both. It's not a solution. Question 2. Let's fill these in. X is 3 minus 2 times y. Y is negative 1 equals 5. So 3, very good, plus 2 equals 5. True or not true? True. Let's check the other one. 2 times 3 minus negative 1 equals 7. So I rewrite it as 6 plus 1 equals 7. True or not true? True. So this is a solution. So let's put yes. So really, we know this has at least one solution. Okay, so the answer here could be one solution or all real solutions. Does that make sense? The only way we could tell is if we solve both of these for y and saw if they were actually the same equation. If they're the same equation, it's coinciding lines. Right? But that's really not what they're asking us to do. But yes, it is a solution. Correct? Okay. Let's skip down to number 4. Solve each system by graphing. Number 4, they're both in slope-intercept form. So what do I need to find in those equations? Slope and what? Y-intercept. So for the first one, my slope is 1/2. My y-intercept is 0. Very good. So if my y-intercept is 0, where do I start? At the origin. Good. 0, 0. From there, what do I do? Very good. Rise 1, run 2. I want you to put as many points as you can on that graph. Okay, for the second part, what was the slope? Negative 1. What is the y-intercept? What? 3. Good. So where do I start? Huh? Where do I start at? 3. Where at? Up, down, left, or right? Up 3, right? Start there. From there, what do I do? Up 1 over 1? It's negative 1. Down 1 over 1. The point they have in common, I want you to circle. How many solutions? One solution. So let's write one solution. And what is that solution? What's that solution? What order pair is that? 2, 1. Okay, so if I ask you how many, you say 1, and if I ask you what it is, you say 2, 1. Alright? Okay, let's get down to number 6. What's wrong with number 6? So what's wrong with it? It's not in slope-intercept form, so we've got to put it in slope-intercept form, right? Okay, so if I have negative 2x minus y equals 1, what do I need to do? Very good. Add 2x to both sides. So that gives me negative y equals 3x. Can I combine something that doesn't have an x? 1 plus 2x, or let's do 2x plus 1. I like the x first. Am I done? No. What do I need to do? Subtract 1? Where's a 1 at that I need to subtract? I need to what? Very good. Divide by negative 1. That y needs to be positive. So I have y equals negative 2x minus 1. So my m is negative 2. My b is negative 1. So what do I do here? What do I start at? Negative 1. My y-intercept of negative 1. From there, what do I do? Very good. Down 2 over 1. You guys are starting to get the hang of it. My line's not very straight. Okay, in the second equation I have x plus y equal 3. What's got to happen here? Very good. Subtract x. So that leaves me with 3 minus x, or negative x plus 3. If it's slope-intercept form, you want the x term first, right? So my m is negative 1. My b is, okay, so I'm starting from 3. And from there, what do I do? Down 1 over 1. How many solutions? 1. So we have 1 solution. And what is that solution? What's the x value of this point here? Very good. Negative 4. And what's the y value? 7. Negative 4, 7 is our solution. All right, number 7. X equals 3. Does anybody remember anything about something that's missing a y? If it's missing a y, what is it? Very good. It's a vertical line. Is it a function? No, anything that doesn't have a y is not a function. So it's going to have an undefined slope. So we're going to have x equals 3. So we're going to go to where x is 3. And this is going to be a non-function vertical line. Right? Anything that's vertical is not a function. Okay, now the second part of y equals negative 4, that is a function because it does have a y, right? But what is my slope? 0, good. And my y-intercept is? Negative 4. Now what did 0 slope look like? Good, horizontal. So I'm going to go to y of negative 4, and it's going to be a horizontal line. And it looks like they're crossing right there. How many solutions? So one solution. And what is that solution? Whoa, I have like 5 answers for this point right here. Remember, it's x value first. So what's the x value? 3. What's the y value? Negative 4. Okay, let's turn it over to the back. You're going to do it later. Number 8. First part's done. What's slope? What's the y-intercept? 5. So go up to 5. 1, 2, 3, 4, 5. Slope is negative 1, so what do I do? Good. Okay, for the second part I have x plus y equal 5. How do I solve for y? Subtract x. Very good. So that leaves me with very good. What do you guys notice? Same slope. So my m is negative 1. What's my b value? 5. It's the same equation. So what do I know? It's coinciding. So how many solutions do I have? All real solutions. Or you can draw that double-backed R. Okay, number 9. My m is negative 3. My b is? So I start at 2. And from there, what do I do? Down 3 over 1. Very good. Okay, for the second one, what's my slope? Negative 3. What's my y-intercept? 0. So where do I start? 0. What do I do? Down 3 over 1. These are really close together, aren't they? Okay, do you guys notice anything about these graphs? Good, they're parallel. How do we know, though, that they're parallel? How do we know they never touch? No, not because the y-intercept's 0. How do we know that two lines are parallel? Very good. Same slope. Their slopes are both -3, so I want you to put a little note. Same slope. If they're the same slope, we know they're parallel. Well, they have to say have the same slope and different y-intercepts. Okay, but we have two different lines. Okay, so how many solutions? 0 solutions. So this one's going to have no solutions. Okay, some values for two linear equations are shown in the tables below. Find your solution. I'm given two tables. What do I need to find? Their slopes and y-intercepts, right? So I really need to come up with an equation. One way we learned to do it was with the calculator. Remember, you can put it into lists and spreadsheets? You guys remember that? Yeah. Okay, but at home, you're not going to have that calculator. So we have to be able to do it by hand. That's when we did the 3-part table. You guys remember? Yeah. Okay, so let's write it in. 0, 1, 2, 3. And I find slope by going change in x is +1. Change in y was -1. Now my slope, was it y over x or x over y? Y over x. So it's -1 over 1, which is going to give me a slope of -1. So over here I should be able to say -1x, right? So if these are my x values, -1 times 0 is -1 times 1, -1, -1 times 2, -1 times 3. Okay, so 0 plus what is 4? So plus 4. -1 plus what is 3? Does plus 4 work for all of them? So then we did it right. So -1x plus 4. So my equation is y equals -1x plus 4. Okay, for equation 2. Let's make our table. My change in x is +2. My change in y is +4. So my slope is going to be, very good, 4 over 2, which gives me 2. So I should be able to say 2x. So down here I'm going to write 2 times 0? 0. 2 times 2? 2 times 4? 8. 2 times 6? 12. Okay, 0 plus what is 1? So let's try plus 1 in all of them. Does that work? So it must have been y equals 2x plus 1. So now for our graph. The first one, my m was -1. My b is 4. So if I go up to 4, 1, 2, 3, 4. My slope is -1, so I go down 1 over 1. Right? Over here, my slope is, my y-intercept is, so I start at 1, and then what? Up 2 over 1, and that's actually that point there. So what is my solution? 1, 1, 2, 3.